We are moving into chapter 9. So we did chapter 8, and then we'll do 2 sections in chapter 9, and then you'll be good for your next test. So we did 8-1, 8-2, 8-3, 8-5, 9-1, and 9-2. We have a test on 8 and 9. And then we've got 2 more chapters after that, 3 and 10. And then that's all she wrote for Finite. So chapter 9, we're going to go back to matrices. And we are going to talk about what's Markov chains. So we're going to look at Markov chains. Our goal is to explore systems and different states or outcomes that can happen. We're going to use stochastic processes to show how a system evolves from one state to another using probabilities. State just means a certain time period. So like state 0 is like where you start. State 1 would be after a set time period, how things shift. State 2 would be after a second set time period, how things have shifted, so on and so forth. So I'm going to look at an example, and then I'll show you how this all kind of works together and relates. Says, an insurance company classifies drivers as low risk if they are accident-free for 1 year. Past records indicate that 90% of drivers that are low risk will remain in that category next year. 78% of drivers who are not low risk 1 year will be in the low risk category next year. So step 1, create a transition diagram, which is a diagram showing the probabilities determined by research. So a transition diagram is just going to put letters inside circles for the different categories we have, and then we're going to draw arrows that show movement. So do you stay in this category? Do you move to the other category? And we're going to then attach the percents to those arrows. So we have 2 classifications. You are either low risk or not low risk, or L complement, because remember the complement means not or the opposite. The first statement that we have with a probability says past records indicate 98% of the drivers that are low risk will remain in that category. So what I'm going to do is I'm going to draw an arrow from L back to L because they're staying within that group. Now 98% is 0.98. However many circles you have is how many arrows you need to have coming off of each circle. So if 98% are going to stay within this L category, how many percent are going to actually become not low risk? Have an accident? 2%. Yep. So the remaining 2% are going to swap categories to the other side. 2% is 0.02. Now, the next one says 78% of drivers who are not low risk, that are currently over here in the L not category, will be in the low risk category next year. So that's a transition to move over here. 78% in the L not are going to move to the Ls. So 0.78. If 78% leave the category, what percent stay within the category? How much is left? 22. So 0.22. So in one cycle or one state, all 4 of these transitions are going to happen. 98% will stay in L, 2% will leave. 22% stay in L not, 78% leave L not. So every cycle through, that happens. Now, we can take this and turn it into what's called our transition probability matrix. So our transition probability matrix is going to be a constant square matrix that shows the probability of moving from one state to another state, or the ith state to the jth state on the next observation. So basically, we're just going to put all those numbers into a matrix now. And the easiest way to do that is to label your, on the outside here, your rows and your columns. So L, L naught, L, L naught. What you have to make sure you understand, though, is the left-hand side is your current state. And the column up here, the top value, is going to be where you go in the next state. So when I fill this in, to get this upper left spot here, I am starting in L and remaining in L. So starting in L, remaining in L was 0.98. Then one next to it is those that start in L and move to L naught, which is the remaining 0.02. Note, every row will sum to 1. So if I go back and look at those that start in L naught and move to L, so start in L naught and move to L was 0.78. And then we had 0.22 that stayed within the group. Again, if I add those two together, I do get a sum of 1. The next thing you'll be given is what is called your initial state matrix. This is going to be the initial values that we have for this scenario. It says, if we know that 90% of the drivers are currently low risk, what is the initial state matrix? And then what will be the values next year? So if we can find our current state, our initial state is called state 0. So anytime you're talking about a state matrix, it is going to be a row matrix, and you're just going to list all the initial values you have. So we have L, L naught. 90% are currently in the L category, leaving 10% in the L naught category. If I want to find what happens next year, okay, I'm working at this insurance company. I currently have 90% no accident drivers, 10% that had an accident in the last year. And I want to know what I'm going to have next year. Well, next year is going to be state 1. It's going to be 1 year from the previous, so state 1. How do I do that? I take my initial matrix, and I'm going to times it by the transition matrix we just wrote on the previous page. So anytime you want to find what happens, you're going to multiply your state matrix by your transition matrix. It's going to give you a next state matrix. Let me grab my matrix calculator quick. All right, so have a single row, 0.90, 0.10. 2 by 2, 0.98, 0.02, 0.78, 0.22. And then I'm just going to multiply A times B, and it's going to give me my next state. So after 1 year cycle, I will now have 96% without an accident and only 4% with an accident. Okay, so 96% are in the low risk, aka no accident. And then 4% are in the, I guess we would say not low risk, or you could say high risk. 4%, and they had an accident. And then if I wanted to keep going through this process, like if I wanted to find, okay, well, what's going to happen in the next year? Well, I would take this one, the previous, and again, times it by the transition matrix right here. And then that's going to give me, what do I have the following year? That is if there are no external factors, right? I mentioned the term Markov chains. Basically, it's going to be a sequence of experiments, trials, and observations such that the transition probability matrix from one state to the next is constant. So our goal is we are keeping that transition probability matrix consistent so that we can make predictions for future years, future months, depending on what the time frame is for each state. So instead of doing 2 states, now we're going to look at one that has 3 states here. This Markov chain has 3 states, A, B, and C. So I'm going to put A in a circle, B in a circle, and C in a circle. The probability of going from state A to B in one trial is 0.8. So A to B, 0.8. The probability of going from B to A is 0.15. All right, I'm going to pick different colors coming out of each circle. So coming out of B is 0.15. The probability of going from A to C, so coming out of A, I did blue, is 0.15. The probability of going from C to B is 0.2. Let's make that red. So coming out of C to B, 0.2. The probability of going from B to C is 0.15. So coming out of B, I made green, 0.15. And the probability of going from C to A is 0.35. C to A, 0.35. Our diagram is not complete because we have 3 states, and that means there should be 3 arrows coming out of each shape. Well, all it gave me was how I move from one to another. It didn't tell me how many stay within my category. But if I have a total of 3, so if working with C here, 20% come out to B, 35% come out to A. So that's counted for 55% that we've used. So that means the remaining 45% stay within C. So if I add all 3 red arrows, I should get 1. So now if I go to A was my blue arrows here. I've done 0.8 and 0.15. That's going to give me 0.95. So I'm short 0.05. So 0.05 or 5% are going to stay within A. And then B, 15 and 15 makes 30. So we've got 70 remaining. 70 stay within B. So now we can turn this into our matrix. So I will keep them in order A, B, C, A, B, C. All right, so I'm going to do the first row. A to A, 0.05. A to B is 0.8. A to C is 0.15. Next row, B to A was 0.15, B to B was 0.70, and B to C was 0.15. C to A is 0.35, C to B was 0.2, and C to C is 0.45. Okay, so that's my transition matrix T. So if I know where I start is 20% are currently in A, 30% are currently in B, and 50% are currently in C. But I want to figure out S1. I'm going to take S0 and times it by the transition matrix T. Right, I need 1 row, 3 columns, 0.2, 0.3, and 0.5. And then a 3 by 3, 0.05, 0.8, 0.15, 0.15, 0.7, 0.15, 0.35, 0.2, 0.45. Then I'm just going to multiply them. So C times D gives me now 23% in A, 47% in B, 30% in C. I'm going to write those here. 0.23, 0.47, and 0.3. 23% A, 47% B, 30% C. If I want to find the next state, I'm going to take this one that I just found, S1, and times by that transition matrix T. So I don't need to retype my transition matrix. That's already in there. But I do need to now put this guy that we just got as a new matrix. So 0.23, 0.47, 0.3 is what I want to multiply now by my transition D. So now I have, I'll write these down here, 0.187 in A, 0.573 in B, and 0.24 in C. So I've dropped to 18.7% in A, 57.3% in B, and 24% in C. So it looks like there's a lot more movement to what letter? Where's the most movement happening? B. Yep, and how do you know that? The percentage is getting higher, exactly. We can see it looks like A went up a little bit, but then it dropped. C stayed at 30 and then dropped to 24. So we are seeing more funneling moving to B. Questions so far? Making sense? We can continue this process for as many times as we want. So I can find state 1 by taking state 0 times P. I can find state 2 by taking the previous value, state 1, times P, also known as take your initial state times P squared. If I want to find state 3, that's going to take the previous value, this guy right here, times it by P, which is the initial state times P cubed. So basically, all I need to do to find any state, whatever state I want, S, N, you're going to take your initial state times by, they use P to represent the transition matrix here. I wrote a T on the last slide. Doesn't matter. So transition, however many times you want to go through. So if you want to find the 5th state, you're going to take state 0 times the transition to the 5th power. And I will confirm with you here that I didn't have to go back and do this part here. I could have just done C. I want to cycle through D twice. Did I get the same answer? Yes. So could I figure out where I am 5 times down the line? Sure. If we are given a transition matrix of 0.8, 0.2, 0.3, 0.7, and our initial state matrix of 0.8 and 0.2, find P to the 4th power and then state 4. So all I need to do, honestly, is just go to my calculator over here. So let's put in our transition, 0.8, 0.2, 0.3, and 0.7. And get rid of a row, 0.8 and 0.2. All right, so they want to know, what is the transition matrix to the 4th power? Well, my transition matrix for mine is letter F. So F to the 4th power is going to give me those decimals. So if they wanted me to write that, I could write that over here. 0.625, 0.375, 0.5625, 0.4375. And every time, no matter what, if you add the row, any row will always get to 1. That's how you know it's right. Okay, if we want to find state 4, I'm going to take initial state times transition to the 4th power. So I started with 80% in state 1, or sorry, in outcome 1, and 20% in outcome 2. I'm now at 61.25% in outcome 1 and 38.75% in outcome 2. So S4, 0.6125 and 0.3875. All right, next one. A Midwestern university offers its employees 3 choices for healthcare: a clinic-based health maintenance organization, or an HMO, a preferred provider organization, aka PPO, or a traditional fee-for-service program called FFS. Each year, the university designates an open enrollment period during which employees may change from one health plan to another. So you can see we've got 3 states, right? Hopefully at this point, since we've done enough, you don't have to draw the transition diagram with all the circles. We can just go straight to the matrix. So I'm going to put HMO, PPO, fee for service, HPF. All right, so let's see what we got here. That's going to give me my, as I read this is my initial state. Prior to the last enrollment period, 20% were enrolled in HMO. So my initial state, 20% HMO, 25 in PPO, and the remainder in FFS. So we've used 45%, that leaves 55. So currently HPF, these are our values. During the open enrollment period, 15% of employees in HMO switched to PPO. So I'm working on this first row here. They're in H, they switched to PPO, 15%. 5% switched to the FFS. Okay, so 20% have moved out of the category. How many remained? 80. All right. Next, it says 20% of those in PPO switched to HMO. So P to H was 20%. 10 went to FFS. So 10 went there. They're always giving you how they move out. They don't ever give you what stays there. That's the one you calculate. So 30% left the category. That leaves 70% that stayed in the PPO group. 25% in the FFS switched to the HMO, and 30 switched to PPO. So 55% came out, leaves 45% that stayed in the group. That is our transition matrix. Then we have 2 questions to answer. What percentage of employees were enrolled in each health plan after the last enrollment period? So we want to know, after we go through an open enrollment, where are we? What is state 1? And then C says if this trend continues, what percentage of employees will be enrolled in each plan after the next open enrollment period? So that wants to go another state to state 2. So for state 1, you take your initial times your transition, just one time. If I want state 2, I'm going to go through the transition matrix twice or to a power of 2. No row, column. Okay, 20, 25, 55. 20, 25, 55. Then a 3 by 3. 15.05. 20, 0.70, 0.10, 0.25, 0.30, 0.45. All right, so cycle 1 is just going to be A times B. And then cycle 2 will be AB squared. I will copy those over here, 0.3475, 37, and 2825. And then the second one was 4226, 3959, and 0.1815. And remember, this is the HMO percentage, the PPO percentage, and the fee for service percentage. So we started with 20% HMO, 25% PPO, 55% fee for service. After one open enrollment period, we're up to 34.75 in the HMO, 37% in the PPO, and 28.25 in the fee for service. If the trend continues in the next year, we will have 42.26% in the HMO, 39.59% in the PPO, and 18.15% in the fee for service. And hopefully that makes sense. You've probably heard of HMO and PPO, maybe not of a fee for service. And generally, those are the two most common ones. So it would kind of make sense that we would see a few more people filtering into those plans over the fee for service. All right, so I'm going to let you guys try this one. This is our last example for today. Says the 2000 census reported that 41.9% of households in the District of Columbia were homeowners and the remainders were renters. During the next decade, 15.3% of the homeowners became renters and the rest continued to be homeowners. Similarly, 17.4% of renters became homeowners and the rest continued to rent. Write your transition matrix. According to this transition matrix, what percent of households were homeowners in 2010? So we are going to take, it says here, during the next decade. A decade is 10 years. So every 10-year period is another cycle through. So from 2000 to 2010, one cycle. You're then going to predict where you'll be in 2030. Okay? If you started in 2000 and you went to 2030, how many decades, how many cycles have passed? So you guys try that. I'll give you a few minutes and then we'll check it up here. And then you're done for today. Were you guys able to get your initial steady state matrix? Sorry, initial state, 0.419 and 0.581. And then transition, 0.847, 0.153. And then 0.174 and 0.826. For B, we just wanted to find state 1, sorry, state 1, which is state 0 times my transition matrix. And if I did that, I got 0.456 and 0.544. For C, 2030 means I want to find state 3 because 30 years has passed. That is 3 decades. So I'll take state 0 times the transition cubed. And for that, I got 0.498 and 0.502. That's all we're going to do today. What we're going to look at next class is what's called the steady state matrix, or basically future end goal, where are things going to end up? Eventually it stops transitioning and it just stays steady. So that's what we're going to look at on Thursday. If you did not do the roulette discussion board from last class, do that. And homework for the rest of chapter 8 is due tonight. So if you haven't done that yet, please do that as well. Otherwise, I'll see you Thursday.